Howdy, y'all. I'm Matt, Chief of the Flutter Bounty Hunters. Welcome to On the Hunt, a Flutter podcast. Today, we're talking about 10 things that Flutter should do in 2023. Let's get into it.
We learn unique lessons about how to work with Flutter and Dart. And then we open source that work for the rest of the community. I am a Flutter maximalist.
It's nearly the end of 2022, and that means it's time to take inventory of what we'd like to see come to Flutter in 2023. At the Flutter Bounty Hunters, we work on a variety of open source packages, which put us face to face with a diverse set of Flutter limitations. So here's what we think the Flutter team should deliver in 2023. Number 1, full fragment shader support. Fragment shaders are the ultimate escape hatch for UI rendering. Any painting that doesn't fit in Flutter's standard framework pipeline can be painted to a texture with a shader. Shaders offer unparalleled rendering performance, they offer pixel level access, and they can modify existing textures which were painted by other shaders. Flutter currently ships partial support for custom shaders. However, there are many aspects of common shader languages that Flutter doesn't support. Additionally, Flutter has shied away from runtime shader compilation, which is necessary for shader effects that, you guessed it, depend upon details that you discover at runtime. Shaders are what I would call a watershed detail. They force a tough decision. When you need a shader, you really need a shader. With Flutter's partial support for fragment shaders, Flutter adopters are forced either to forego the entire feature, they just don't get it, or they're forced to stop using Flutter. As a community, we never want to see developers need to make that decision. And to avoid that tough decision, Flutter should provide complete fragment shader support for those that need it. Number 2, glyph rendering. Flutter got its start in the mobile world where users spend very little time with text content. Mobile apps display short runs of text on buttons, app bars, cards, those kinds of things. There's very little in the world of mobile to really push the limits of text painting. With Flutter now shipping to Mac, Windows, Linux, and web, these large screen affordances invite many document-style user interfaces. So whether you're shipping a productivity app, journaling app, document editor, blog, or email client, you need to display large blobs of text, mingled with non-text content like images and videos. These, quote, content-heavy use cases, which are growing in popularity, require more granular control over how text is painted. Flutter's existing solution is for all text painting to use what are called paragraph objects. These calculate line breaks, and behind the scenes, they position all of the individual glyphs on your behalf. Now, this works fine for some documents, but it fails miserably for others. You see, some document formats already include the glyph positioning choices. Like the document that you're loading has already decided where every glyph is supposed to appear. Text layout is already finished before you ever open the document. But Flutter developers are still forced to use these paragraph objects. And as a result, these document renderers create, measure, and render hundreds, if not thousands, of paragraph objects per page. This is hugely inefficient, and it becomes a bottleneck for performance. It literally prevents some of us from shipping these kinds of experiences. Flutter should expose lower-level typesetting APIs. This includes APIs for placing a small run of glyphs within a line, 2 or 3 or 5 individual characters within one line, as well as painting one glyph at a time. Not only would these APIs facilitate rendering for existing document formats, but it would also open the door for the community to solve general text flow challenges, such as flowing a paragraph of text around an image. text painting is a bottleneck issue for sophisticated desktop use cases. Flutter should remove that bottleneck. Number 3, Dart FFI multi-threaded callbacks. That is one mouthful of words. So first, what is Dart FFI? Let's make sure you're familiar with that. Dart FFI stands for Dart Foreign Function Interface. Dart FFI allows your Dart code to call directly into precompiled binary packages or libraries. So you can take some C code. You can compile the C code into binary, and then your Dart code can literally talk directly to the C code using what is called Dart FFI, Foreign Function Interface. Now, Dart FFI opens incredible potential for Flutter and Dart applications. If you look hard enough, you can find an existing C implementation for any problem. In theory, Dart FFI expands the power of Dart to include the existing accomplishments of all C code. But there's one critical piece that's missing. Dart can't deal with common C library callbacks. At the Flutter Bounty Hunters, we've investigated using Dart FFI to integrate various capabilities such as audio synthesis, as well as using Dart FFI to talk directly to the Flutter engine, and we've repeatedly hit a wall with these callbacks. Think about all the places in your Dart code where you accept a callback as a delegate. All the places where you take in a function and later you call it back to do something. Well, this pattern is prevalent in every language, including C. For example, in an audio synthesis package, the audio package calls you back to get whatever audio samples you want to play through the speakers. Now, this control is immensely powerful. You're no longer a slave to the overly complex and underspecified Android and iOS audio APIs. You can literally play whatever sound you want. You can generate audio samples with an algorithm or a mixer. But you can't do this in Dart, not as it stands today. When a C package runs your callback, the C package often executes your callback on a background thread. And this is very, very common. Let's not forget that C is often used to gain fine-grained control over both memory and CPU utilization. And what's one of the most popular tools for minimizing CPU workload? It's to move work onto other threads to take advantage of multiple cores. So it's very common for C packages to move work onto other threads, and if they happen to invoke a callback on a different thread, well, Dart can't really handle that. If you try to access any surrounding information within your Dart callback, like if your Dart callback code reaches out and accesses a variable outside the callback, Dart blows up. And this is because from a Dart perspective, your primary Dart code is running in the main Dart isolate, and then the C code calls you back in a different isolate. And Dart has very strict rules about accessing information across isolate boundaries. So when you try to access something from your callback, Dart blows up. And the thing is, these callbacks are useless if you can't access any other information in your app. For example, let's go back to the audio synthesis example. If you're filling an audio buffer, obviously those audio samples come from somewhere else in your code. But you can't access those samples because of those isolate issues, because of the threading issues. This seemingly minor limitation turns out to be a massive bottleneck for Dart FFI effectiveness. For the most part, we've actually stopped attempting to use Dart FFI to wrap powerful packages because this issue keeps repeating itself. So we would love to see a fix for this as soon as possible. Number 4, refactor the text input system. Flutter's text input system has worked fine for mobile apps with limited text editing. Today, Flutter is focused on far more than mobile form factors, and Flutter text editing use cases on all platforms are growing in complexity by the day. I think it's time for Flutter to step back and reimagine their text input architecture because it's a problem. At the Flutter Bounty Hunters, with our work on Super Editor, we have a unique level of exposure to Flutter's text input system. In fact, our work on Super Editor was the forcing function to get Flutter to implement text editing deltas. With the rate that Flutter keeps breaking Super Editor, it's clear that Flutter has the wrong architecture for its text input system given current and future goals. At the highest level, the problem with Flutter's text input system is that it violates what is called the open-closed principle. That principle states that code should be open for extension, meaning you can add new things to the existing code, but closed for modification, meaning that when you add new behaviors, you're not allowed to accomplish that by altering existing code or existing behaviors. To achieve this goal, one must design and engineer an API that exposes the natural axes of change so that future developers can extend the existing behavior without altering the existing behavior. This is much easier said than done, but it is doable and it's worth the effort. Flutter made two choices that make it impossible to implement the open-close principle for text input. First, Flutter doesn't provide app-level access to each platform's text input signals. In other words, you never really respond to iOS text input or Android text input. You just respond to this general concept of Flutter text input. Now, there are problems with that decision on its own, but that decision alone isn't a massive problem. We could get around it. But when that decision is combined with the second choice, it is a big problem. And the second choice is that the Flutter text input signals are woefully incomplete. There are dozens of text input signals, or at least content editing signals, including on mobile platforms, that Flutter simply doesn't report. As a result, there is exactly one place in Flutter to receive text input signals, and dozens of those signals are hidden from you. They are inaccessible. The way that Flutter adds those missing text input features is by altering the public API of this one central set of text input signals. So every time that Flutter adds a new signal, in other words, adds a new public interface method, Flutter breaks all implementations, either literally or figuratively. Either your implementation ends up with a compilation error that's literally breaking you, or your implementation silently fails to do the new thing that it's supposed to do. The way that's the figurative breaking you. And the way that works is that you'll upgrade Flutter, everything compiles, you assume everything is fine, but then as you start using your app, certain text input behaviors just don't do what they're supposed to do anymore. And you'll spend days or weeks trying to track this down. Eventually, you'll discover that this method was silently added to the core text input interface, and then Flutter made other changes in the framework, assuming that that method is implemented. But you and I, we might have a custom text input implementation. We didn't implement that method. We didn't know it was there. Nothing told us we had something to do. And so other things broke silently. I think it's time for Flutter to recognize that every platform includes a similar but distinct set of text input signals. Flutter currently supports a small fraction of those signals. Flutter will eventually need to support all of those signals. And that's an important point as well. I'm not sure people on the Flutter team really have thought about this and understand this. But consider anything and everything that iOS, Android, the browser, Mac, Windows, Linux does from a content editing standpoint. Think about the APIs that those operating systems provide to developers like you and me for content editing. Do we think that those operating systems added capabilities that nobody wanted or needed? Of course not. The reason that those operating systems created those APIs is because developers like you and me needed them. We will eventually need them with Flutter. If Flutter succeeds the way we hope it does, if Flutter goes everywhere and does everything for user interfaces, all of those APIs will eventually be needed in Flutter. Because content editing is literally fundamentally a user interface behavior, and Flutter is a portable UI toolkit. This is what Flutter exists to do. Flutter has three modes of input, three responsibilities: render pixels, handle gestures, process text input. That third one is what we're talking about. So eventually, Flutter is going to need to support all of those signals. Therefore, the smart thing to do is to re-engineer the text input API so that it's open for extension, but closed for modification. That way, the ecosystem isn't constantly processing breaking changes from Flutter just because one more signal was added. Number 5, widget toolkits for every platform. One of Flutter's most powerful tools for early adoption was platform widget toolkits. For Android, Flutter boasted a material design components implementation that was actually more accurate than the one that was implemented for Android. Additionally, Flutter made sure to provide Cupertino widgets for all the iOS developers who needed to continue to reflect iOS expectations. The investment in these not strictly necessary packages paid dividends and paved the way for mass adoption on mobile. The Flutter team should repeat this strategy for all platforms. Mac and Windows each promote a unique design language and set of common UI components. There should be robust, complete packages that provide the relevant assortment of widgets. Now, there are some community efforts along those lines, but those community efforts, those community packages to create Mac and Windows widgets, they aren't complete. And in a moment, I'll discuss what the Flutter team should do about that. But before we get to that, Linux and web. Let's mention Linux and web. Linux and web lack a strong opinion about UI components. And that's because Linux distributions are so diverse that Linux itself has little to say about interfaces. I mean, maybe Ubuntu does, but Linux on the whole probably doesn't. And when I say the web, what I'm really talking about is the browser. Well, browsers are diverse, and regardless of that diversity, the Chrome in the browser, the styling of the browser UI isn't supposed to have any impact over web pages. As a result, there's no design language for Linux and web, but there are common UI patterns that apply to these large screen experiences. It's important to provide great tools for those patterns too. So what should Flutter do about this? Should Flutter add 3 or 4 more packages to the framework? No, absolutely not. In fact, I am of the strong opinion that Flutter should remove Material and Cupertino from the framework and release Material and Cupertino as packages on pub. And this is because the existence of those packages in the framework, it is so confusing that even Flutter framework developers keep mixing and matching these things in a way that's ruining divisions of responsibility. But I'm going off on a tangent here. That's a conversation for another day. My point is, Flutter certainly shouldn't add more non-framework things to the framework, okay? In fact, I don't even think the Flutter team should work on these new platform widget toolkits. Instead, the Flutter team should pay the community to build and maintain these packages. And I really do mean the community. Those of us who are intimately familiar with the Flutter organization, we know that there are 3 or 4 companies that currently have a special financial relationship with the Flutter team. They are part of the community, but they do not constitute the community. The community is much larger. So when I say the Flutter team should pay the community, I mean find more developers who are familiar with these responsibilities, who are good at creating these widgets, and go support them, go fund them. The Flutter team should establish a budget that pays the existing project maintainers for the Mac and Windows toolkit packages. So somewhere in the community, there is a known package working on Mac-style widgets. There is also a known package working on Windows-style widgets. The Flutter team should establish a budget and pay the maintainers of those projects. And when the Flutter team does that, the maintainers of those projects should also add more experienced community developers to their effort, because we need them to move faster, to make more progress, and to maintain quality. And so they should they should diversify their own team. I think right now there's one primary developer on each of those packages. That should be around 3 or 4, I think. So the Flutter team should pay those packages, and those package authors should create a little team, and those little teams should expand the packages and maintain them. As mentioned previously, platform widget toolkits have already proven themselves as immensely valuable. Remember Material and Cupertino? Those were very valuable in helping Flutter receive adoption or obtain adoption on mobile. Now, those packages are valuable, which means the time invested in those packages is valuable. And this is why the Flutter team should pay for that value, and then the Flutter team can reap the rewards of the adoption. So Flutter pays for the development, more people adopt on Mac and Windows, and the Flutter team receives that adoption as a reward. But also, the financial burden doesn't need to be completely shouldered by the Flutter team. The Flutter team can recruit enterprise clients to help with the funding. For example, crazy idea, what if Microsoft pays a few bucks for the Windows style Flutter package? Wouldn't that make a little bit of sense? I mean, they had enough money to buy GitHub. Something tells me they have enough money to pay the Flutter community to build a Windows style toolkit. At the Flutter Bounty Hunters, we're notoriously opposed to the quote, hope and pray model for open source. Whether it's our team working on paid projects or another team, we want to see the power of business models applied to critical shared tooling and infrastructure. The Flutter team should start organizing funding for major community projects in 2023, especially and including platform widget toolkits. Number 6, shared image memory. Flutter is great at working with painting commands, but admittedly, it is terrible at working with individual pixels. One of our packages, Flutter Processing, and its internal painting package, called Bitmap Canvas, are highly constrained by Flutter's lack of pixel painting control. The most significant issue at the heart of Flutter's pixel painting problem is that the Flutter engine refuses to share bitmap memory with the framework. Of course, we all know that immutability brings a lot of memory safety, and sometimes it brings performance improvements. But when it comes to painting pixels, this memory ownership makes it impractical to use Flutter to paint pixels. Every time that you want Flutter to display a new bitmap image, including a slightly different version of an existing bitmap image, you need to upload that pixel data into the Flutter engine, which is an asynchronous operation, which takes a long time. And then every time you want to change even one single pixel in an image that's currently in the Flutter engine, you need to download the pixel data from the Flutter engine, which again is an asynchronous operation, and it takes a long time. Flutter makes it easy to paint lines and curves and rectangles and ovals and paragraphs on every single frame. There's no reason that it shouldn't be easy to set the colors of individual pixels on every frame too. Flutter should bring us the power of mutable bitmaps that are shared with the engine. Number 7, platform views on Mac. With our work on our FFmpeg CLI package and our cutting room package, we've been waiting years for the opportunity to build a basic video editor with Flutter on Mac. Unfortunately, there's a missing piece that has made this impractical, and that is Flutter doesn't support platform views on Mac. A platform view is a Flutter widget that renders a traditional platform view. Think of like an actual Android view or an iOS view, a Mac view, a Windows view. Flutter renders that platform view as if it's part of Flutter. This is actually how Google Maps are rendered in your Flutter mobile apps. Flutter is not rendering that map. They didn't create a special map renderer for Flutter. They use their existing rendering system. Flutter punches a hole, cuts a rectangle out of the screen and shows the map. Now, according to various people on GitHub, video rendering on Mac requires platform views, but Flutter hasn't implemented platform views for Mac. Flutter should bring platform views to Mac for all the many use cases, which are only possible by displaying standard Mac views in our Flutter layouts, including, of course, the ability to display video frames. Number 8, vend textures from Dart. Textures are a uniquely powerful construct in UI rendering. They're kind of like the counterpart to fragment shaders that we mentioned earlier. By displaying arbitrary textures, Flutter gives developers the power to use non-Flutter tools to paint visuals and then display those visuals in Flutter. On mobile, the Video Player plugin uses a texture to render video frames. This is because the Video Player plugin uses sophisticated existing tools to decode and render video. I mean, we wouldn't want the Flutter team to reinvent video rendering, so instead, those video rendering tools render each video frame to a texture. Then, the Video Player plugin tells Flutter to display that texture, and that's how video gets displayed in your Flutter app. There's one really annoying aspect, though, of this shared texture capability. Currently, to get a texture that you can share, you need to call special Android and iOS methods to create the texture, and then get that texture ID from Flutter. You can't do this directly from Dart. So imagine you're integrating a powerful C package to paint something. You have this C package that can paint something that Flutter can't paint. With Dart FFI, you talk directly to this C package. You need to give the C package access to a texture so it can paint to the texture. Well, where do you get the texture? There's nothing that you can call in Dart to create a texture and give a handle, of that texture to the C package. Instead, you'd need to add code for Android, iOS, Mac, Windows, Linux, and web to initialize a texture on each of those different platforms. Then you'd have to figure out how to give control of that texture to the C package, and that's assuming that's even possible. I'm not sure that it is. So Flutter should figure out how to initialize and vend shared textures within Dart in a manner that allows those textures to be painted by packages that are integrated via Dart FFI. Number 9, componentize the engine. Flutter began as a mobile UI toolkit. Mobile use cases only required a small number of visual capabilities, but they demanded absolutely tiny binary sizes so that mobile apps would be quick to download on slow internet connections. Today, Flutter serves desktop UI use cases, which require all sorts of rendering abilities that aren't needed for mobile. So Flutter has a decision to make. Flutter can take one of 3 actions moving forward with its engine. First, Flutter can add desktop UI capabilities to the engine, balloon the binary size, and lose mobile developers due to the size of their apps. Second, Flutter can continue to constrain engine capabilities for the sake of mobile binary size, and then fail to achieve adoption on desktop because those desktop developers don't have the tools that they need. Or third, Flutter can offer different versions of the engine with different levels of capability and different binary sizes. From a long tail standpoint, only one of these options makes sense, and that's to offer different versions of the engine. Consider an example from earlier, individual glyph painting one character at a time. Very few mobile apps require per glyph control. Any such APIs would be wasted on nearly every mobile app. But some apps do need this capability. A growing number of desktop apps are likely to want this power over text layout. In fact, right now we're working with a client that needs this capability. Ironically, that client actually needs it on mobile, so there are some mobile apps that need per glyph layout and rendering, but it's mostly going to be a desktop concern. In any event, at the moment, we're literally reinventing text layout and painting for our client because Flutter chose to hide those lower level typesetting APIs. You may not realize this, but every time you change your Flutter version, you download a new compiled Flutter engine. That's the process that shows the long-running progress bar in your terminal when you type Flutter upgrade. You type Flutter upgrade, and then you see this horizontal kind of bar expanding in your terminal, and it's showing you all the bytes that are being transferred. That thing right there is a precompiled Flutter engine. And that precompiled Flutter engine is hosted by the Flutter team. At the moment, there's only one version of that precompiled engine, for every version of Flutter. But there could be more. If the Flutter team adjusted the engine's implementation so that there were pluggable encapsulation boundaries, the Flutter team could publish 2 or 3 or 4 versions of the engine, all with different levels of capability. Similarly, check out this crazy idea. The Flutter team could provide a web app where you customize your own engine a la carte. This approach would allow every app developer to individually balance the need for rendering capabilities with the need for minimal binary size. It's an all-you-can-eat Flutter engine buffet. Number 10, refocus on the core of the framework. You'll notice a common theme throughout the items that I've raised today. They're all about limitations at the core of the framework. We didn't mention anything in this discussion about creating new material widgets in the framework, or adding more properties to existing Cupertino widgets, or adding some new obscure layout widget. We're not talking about tweaking the extremities of Flutter, we're talking about substantive central improvements. Over the past few years, I've observed a lot of work within Flutter's user-facing widgets. The framework developers add some properties here, fix some little bugs there, add some if statements for a new platform here, alter some internal widget behavior there. It's a lot of simple stuff that frankly any developer in the community is capable of contributing. But there are a lot of details in Flutter that only the framework team can handle. Those specialized tasks get abandoned when the Flutter framework team focuses on the little details on the periphery. I'd like to see the Flutter framework team focus more on those details which can only be handled by the framework team. If a widget needs some new properties or a minor bug needs to be fixed, then give that task to someone in the community. I mean, at the Flutter Bounty Hunters, we'd be happy to contract with the Flutter team to solve the simple stuff and help the framework team focus on the complex stuff. We'd also be happy to consult with the Flutter team on core API refactoring, such as refactoring Flutter's text input system. But in both cases, the Flutter framework team needs to decide to prioritize the stuff at the core of the framework instead of grabbing the low-hanging fruit at the periphery. Flutter's framework labor is so greatly constrained, meaning the team is so small, that the framework team must ensure that for each change they make, hundreds or thousands of doors of opportunity need to open for the community. Only that level of amplified impact will allow such a small Flutter framework team to continue delivering what the global Flutter community wants and needs. So those are our top 10 items that we'd like to see come to Flutter in 2023. What do you think? Do you agree? Do you disagree? Do we miss things on the list? On our end, we're hoping that at least some of these issues make it into Flutter's roadmap for 2023. I will say that if any of these items are important to you, consider sharing this podcast and also consider going to the blog, get the link for this page, and share that around as well. The more that these interests are promoted, the more likely that they'll be taken seriously by the Flutter team. So with that, have a great 2023, and y'all come back now. You hear?